Hi, today we're going to talk about the principles of Boolean Algebra as a part of a series of tutorials about electrical and computer engineering topics. So let's start it. So as you have seen, probably almost all digital and electronic circuits are operated in two-valued binary system. Binary systems were very well used by classical cultures and was called prepositional logic, where prepositions were true or false. The prepositions can be connected between each other by using the operations and, or, and not. So let's see an example so we can understand all this better. The example is this one over here. It says, I will be happy if I have money or I have health. So we first have to visualize this as a system of input-output. What gives place to what? So in this case, we can visualize our system as a green box. So our output can be, I will be happy, because you have this word if. It gives you like a relationship of cause and effect. The cause is, I have money or I have health, and the effect is I will be happy. So the happiness depends of the person having or not money or health. So in this case, we have our system have two inputs and one output. I have money is one input, I have health is one input, and I will be happy is the other input. The three of them are prepositions that are, two of them are input of the system and the other one is the output. So they are all related, but this the inputs are connected by these or words, so which means that at least one of them have to be truth in order to have a true output. At least one of them have to happen in order to the output to be truth. Let's see it a little bit in more detail. For example, this is a truth table where we put all the inputs and outputs and all the possibilities. So in this case, the OR, we have we center in the operations between the inputs, like in this case the OR. So in this case, the OR, in the first two, the inputs, I have money, I have health, and the output, I will have money. So what happens is the two inputs are false. If the two inputs are false, the output is false, because as I said before, in the OR, at least one of the input events have to be truth in order for the output to be truth, which happens in the second and third one. One of them is true. They exchange values. One of them is truth and the other one is false. So we're going to have a true in the output. But what happens if both of them are truth? If both of them are true, the output is also true, because at least means that one of them can be truth, but also the other one can be truth. So it means that only one or the two of them can be truth. In those circumstances, the output is a truth. Let's change it up a little bit. So what happened instead if we said, I will be happy if I have money and I have health? So we have the same truth table, and our system, the only one difference is that it's going to be joined by an and not by an or, because the and is the central part of the situation here. So the and, as the word said, it means that the two input conditions have to be truth in order for the output to be truth. So let's see it in the truth table. If both inputs are false, then you're going to have a false in the output, because none of them is truth, none of the inputs is truth. But what happens if only one input is truth, as we say in the second or the third line? Well, the output is still false, because both of the input conditions have to be truth in order for the output to be truth. So that's why in the last row, when both inputs is true, we have a true in the output. So the main difference between the and the or is that in the or, at least one of the conditions have to be truth, but in the and, both conditions have to be truth. In the or, you have the option. In the and, you don't. So let's check our new next operation and how this changed. Now, if we have other new statement, I will be happy if I have no money. So this person don't like money. So our system, because we only have one condition in the input and one condition in the output, our condition in the input is I have money, and our condition in the output is says I will be happy. So they are joined, but this word no means that we're going to negate the input, and that will be our output. Let's see it better in the truth table. I have money is our input, and I will be happy is our output. If the input is false, as we negate as the output is a negation of the input, then our output is going to be truth. If the contrary happens, the input is truth. As we negate the output, as we negate the input, I'm sorry, then the output is false. So when we have a not, or a negation, as it calls in Boolean algebra, the output is a negation of the input. So in order for the output to be truth, our input have to be false. The inversion or the not is the most simple operation in Boolean algebra. So let's recap here in this summary. The OR, in order for the output of the OR to be truth, at least one of the input conditions have to be truth. In order for the AND output to be truth, both input conditions have to be truth. So we have in the negation, in the not, if the output is in order for the output to be truth, the input have to be false. The output is always going to be the input, a negation of the input. So these are the three most important blocks of Boolean algebra. If you understand this part, if you understand this basis, you won't have problems to keep working in the field of logic circuits. So that's it for today, and thank you so much for listening to me.